What will happen is that the slip, it will be burned on the outer region. So kuna mtu atapata hii swali akose idea, how do we do it? Just draw it. The moment you draw it, you are going to get all the marks. And that was the first area that is on apparatus. That is on apparatus. Unless there is any question, I can take you through the next area, which is simple classification of substances. Anyone with a question testing on use of apparatus? Okay. So question number, the second main area, you realize that sasa tuko form 1. This is topic number 2, simple classification of substances. So what is tested here? It is mixtures and the separation of mixtures. Number 2, describe the process of separating mixtures correctly. A description is marked procedurally. So that means it is marked up to where it is correct. It is marked up to where it is correct. So once you are giving out the procedure, it must be correct. Then number 3, we have to know how to state the application of the method of separation. How do we state the application of the method of separation? Then the last one, it is the method of separating the mixtures. It's good to understand that we have 11 methods used to separate mixtures. The first one, decadation. This one is to separate solid particles from this is used to separate insoluble solid liquid mixture. We have filtration. Filtration and decadation, they are similar, but filtration is more effective. There is use of magnet. Use of magnet, this one we use it once one of the components are ion filings. That is when we use a magnet. Next, there is sublimation. Once we are using sublimation, one of the components should be capable of going sublimation. Which are these compounds which undergo sublimation? Number 1, we have the dry ice. Number 2, we have solid carbon, dry ice is the solid carbon dioxide. We have ammonium chloride. We have ammonium bromide. We have benzoic acid. We have aluminum chloride, and so on. Another one, evaporation, crystallization, fractional crystallization, simple distillation, fractional distillation, solvent extraction, and chromatography. Sometimes we need to know the difference between fractional distillation and simple distillation. For fractional distillation, we are separating miscible liquids with close but different boiling points, and there must be use of fractionating column. Simple distillation, we may not need a fractionating column. What about the difference between crystallization and fractional crystallization? For fractional crystallization, we need to master what is the solubility of the salts, because fractional crystallization is used to separate solids with close solids whose it is used to separate salts whose solubility is known. So that is what I need you to understand. How has this area been tested? As you can see, in the last 5 years, this area has been richly tested. Look at it. 2020, 3 marks. 2021, 6 marks. 2022, 6 marks. 2023, 3 marks. 2024, 3 marks. So this is an area, once you are preparing for any exam, including the exam that you're going to do. Let's say, I don't know whether in your school you're going to do open exam, but I know those who are from Karima, you better be prepared. You are doing open exam the second week. Wherever you are doing any exam, especially a paper one, this area has high rate of being tested. So, if I may ask, which year would you like us to go through? Maybe I can take you through 2024, and if there is no other question, we can just go to the next because we have a lot. We have a lot to cover today. We have a lot to cover today. So let me show you the question for 2024. 2024, because it is the most recent. 2024. So the question for 2024 was tested in a unique manner. That is the question. Can I have someone to read the question that is on the screen so that we can walk this journey together? Someone to read the question?
The following steps are followed in carrying out paper chromatography of a dye. The solvent is placed in a beaker. A baseline is drawn with a pencil on the paper. The sample is spotted on the baseline. The paper is carefully placed in the beaker with the baseline above the surface of the solvent. The beaker is covered and allowed to stand for some time. Give a reason for the following.
The first one. The baseline.
Give a reason for the following. The baseline is drawn with a pencil.
Very good. Who can give us the reason why? What do you think we have to draw the baseline using a pencil? Someone to give it a trial?
I think it's because pencil is made with. This is because pencil is made with graphite, which does not react with the solvent.
Yeah, which will not dissolve in the solvent. That is good. That is good. Another one, the paper is carefully placed in the beaker with the baseline above the surface of the solvent. Najua hii swali tumeizoea ikiwa hivi ndo inakujanga kwa exam. Tumezoea ikiwa ushachorewa. But sasa unaulizwa, once we are doing this, why is it that hii baseline haifai ingia kwa solvent? Who can give us the reason? What do you think it should not get into the solvent? Okay. I think I can just take you through what was expected response. And this is question number 17. And you can see how the response were. The responses were as follows. Number 17. So you can see the reasons. The reason why, it's like, I think I've stopped sharing, so I can just go back to it. Okay, you can see now they are testing not just on the scale of, I know we are used to, unaulizwa identify the baseline. Circle the one which is impure. Last year they tested how do we do the process. And just as we have been told, the reason why we should use a pencil is that the pencil does not dissolve in the solvent. Therefore, it will not contaminate. That is the reason. It will not dissolve in the solvent. Therefore, it will not contaminate the sample or to avoid impurities in the solvent. That is the first reason. The next one is why do we have to place it in such a manner that, well, just a minute, I admit a few. Why is it that we have to place it in such a manner that the baseline is above? This is the reason. The baseline should not come into contact with the solvent to prevent the dyes from dissolving in the solvent. Why are we doing this? Remember, we carry out the process of chromatography. The baseline hapa ndo uwanga tunaweka hizo dyes. So the moment unaidissolve kwa solvent, you are going to bring contamination. what are you supposed to do? Unaiwekanga such that the paper, the solvent will ascend. That's why it is called ascending chromatography. Ascending chromatography. Then the last question still on that is on, I think I can just go to the question. The last question is, why is the beaker covered? The solvents used for chromatography, we use mainly propanol and ethanol. These are liquids which are very much volatile. So the reason why we should be covering it is to prevent evaporation of the solvent, to prevent evaporation of the solvent. So you can see, they are testing application parts. I know we are used to doing chromatography, but this is the high time, number one, once we are doing it, why should we draw the dye using a pencil? Number two, why do we have to cover it up? Because the solvent might evaporate. Remember, propanol and ethanol, they have very low boiling points. They have very low boiling points. The other thing is that why don't we dissolve the baseline kwa the solvent? It is going to bring contamination. Any question on a simple classification of substances? If you have a question, you can say. So you can see this is an area which has been tested every year since the year 2020. 2020, 3 marks, 2021, 6 marks, 2022, 6 marks, 2023, 3 marks, and 2024, 3 marks. Maybe, is there another year you would like us to see before I proceed to the next? You are free to unmute and you say. If there is no,
I have a question.
Yes, yes.
When drawn for the portion of that paper, chromatography paper, and
Yes.
you're asked how you can get a sample of one of the spots.
Good. How do we recover a sample of one of the spots from the paper? Now we are going to do solvent extraction. We are going to do solvent extraction. So that means, ukiuliza swali kama hiyo, we are going to place it into a solvent. So the dye will dissolve into the solvent. Then now it will dissolve into the solvent. If we need to get the specific dye now, it's a miscible liquid mixture. So we can now carry out fractional distillation. But kama wameuliza, state the method that can be used to extract the spot from the chromatography. It's carrying out solvent extraction. Have I answered your question?
Yes, thank you.
Okay. So any other question before I proceed to the next? All right. If there is no question, I just go to the next area. Today we have 11 areas to look at. The next one, this is another area which is very key. This is another area which is very key. That is air and combustion. Air and combustion. I know you might be asking yourself, nimeruka topic ya acid, bases, and indicators. This is because I had combined it once I was dealing with paper 2. So, sieti nimeiruka. So, air and combustion. What are you supposed to understand? These are the things that you need to ask yourself, because I know sometimes once you are revising for your exam, it is very normal. After revision, you feel like it's like you don't know anything. These are the these are the things that will guide you to know that you have covered it effectively. Number one, you need to check whether at least can you answer the following. So the first one is components. Just a minute. The first one is you need to know the components of air and how do we separate the components of air. We are used to this question, ikiuliza hivi, is air a mixture or is it a compound? So, just a minute, sorry. So, we need to know the components of air. Number two, this is very, very important. Rusting. What are the conditions necessary for rusting? What are the factors that accelerate rusting? Then, experiments used to establish the percentage components of air. Those are the key areas that you need to review, because sometimes once you are revising, you just need to ask yourself, what do I know about this? Just ensure that you know the components of air and how do we separate them. Number two, the process of rusting, conditions necessary for rusting, factors that accelerate rusting. Those are three things. After knowing rusting, which are the conditions necessary for rusting and the factors that do accelerate rusting. Then the next one, experiment to show the percentage of air in the percentage of air used in rusting and also in combustion. Then the last one is the experiment to establish the percentage of components of air. Unless there is anyone who has a preference of the year that we can check. If you don't give me a preference, I'll just be going with the latest, which is 2024. But maybe let me open it to you. Which year would you like us to go through? There is 2021, 2022, 2023, and 2024. Which example would you like us to have a look at? Maybe someone to suggest?
2023.
Yes, 2020?
2023.
Okay. Let's go to
3.
Okay. 2023. I'll use the marking scheme 2023. So, I think I had seen the question somewhere. This is active part of air. Good. You can see the question number 22 here. Just someone to read the question so that I can confirm that we are reading from the same script. Oh, okay. I will, Lois, I will respond to your question, but allow me first to deal with these. You can see this is how the question was. You are told the figure below was used to determine the approximate percentages of major components of air. So you can see, ukawekewa hapa ya kwanza. In this case, they use the smoldering of phosphorus. Then in the next one, wakaleta maji ikiwa imerise. So the first question is, complete the figure to show the setup when it was left until there was no further change. What you need to understand is that the level of water in the beaker will go down, while the level of water in the flask will go up. So completing it was 1 mark. Next now, it was explain how the percentage of major components of air can be calculated. So what do we mean by this? We need to know what is the change in the volume. So this is H1, this is H2, or I can call it H initial and H final. So the expression for this formula will be equal to, we get the difference, and that means it's going to be H1 minus HF all over H1 times 100%. We're going to get the correct answer. As simple as that. Or now, if we need to get the inactive parts of air, it is HF all over H1 times 100. But the question was, this question was to be tested in 2 ways. Ukiangalia hiyo swali vizuri, I know a student will go direct to get the first one. But now, the question was the major components with S. So that means air is made up of 2 components. We have the active part of air and we have the inactive part. So you were to get first the active part of air. That is H1 minus HF all over H1 times 100 for 1 mark. And the next one, it is the inactive air. That is HF all over H1 times 100. I know very well if this question had come in your exam, 80% of us would have just scored 1 mark. So that is one question that is testing on air and combustion. I can take you through the other one. Can take you through the other one. Good. Can we have someone to read the question that is on the screen? I'm doing this just to confirm that we are moving together. Charity, can you read the question? I don't know whether my network is okay, but I think it is. Or James, can you kindly read the question number 18 on your screen? James, kindly. James. Moses.
Small pieces of beryllium, magnesium, and calcium metals were placed in test tubes containing cold distilled water mixed with phenolphthalein indicator as shown in figure 5. State and explain the observations that were made in each of the following test tubes. Test tube 1.
Okay. So what is happening in this case? We are trying to test the active part of air. So the first one here, it is beryllium. It is beryllium. Oh, sorry. This one is for water and hydrogen. Huh? This one is for water and hydrogen, sorry. I just need the exact question for air and combustion. Sorry for that. There is another question for, yeah, this is the question I was looking for. Purity, can you read question number 13? Purity, if you can hear me. Or, yes?
Give the formula of the compound referred to as rust.
Very good. The compound referred to as rust. We just know that rust is hydrated iron 3 oxide. So once you, I know kitabu inakwambianga hydrated iron 3 oxide. Sasa ukiambiwa you give the formula, it is just F2, Fe2, O3, 2 molecules of water. This is the most common. But you remember, we can just give it the value of X equal any value between 1 and 10. So we can just write F2O3, 1 molecule of water, F2O3, 2 molecules of water, and so on and so on. But now, part B, they are testing on the conditions necessary for rusting. Conditions necessary for rusting. If you look at the first one, who can tell us whether we have any missing condition in the first one? Do we have all the conditions necessary for rusting in Roman 1? Okay. So the conditions necessary for rusting, it is water, oxygen. We have water, oxygen. So someone is saying in Roman 1, there is no moisture. But I think we need to know that as long as that, okay, in Roman 1, there was no moisture, but maybe we'll keep on checking. Roman 2, we can see it is tap water. So tap water contains oxygen. Then Roman 3, there is oil. So meaning that the water was boiled. And after boiling the water, it means there is no air. Then Roman 4, there was salt solution and the nails. Now the question is this. This is a question that was tested. Explain why no rusting took place in Roman 3. So the question is testing on the conditions necessary for rusting. And the answer should be absence of oxygen, because boiling removed dissolved oxygen. And we know that oil keeps off oxygen from entering. So that's why there was no rusting in Roman 3. Next one, select the test tube which was having the highest amount of rust. The test tube with the highest amount of rust, it is like they are testing which are the conditions necessary for rusting, or not conditions necessary for rusting, but factors that accelerate rusting. And that is the factors that accelerate rusting. One is salt condition, another one is acidic condition. So you can see it was tested indirect. Factors that accelerate rusting, and the other one, there is chemical name for rust. Then you are also accounting for the observations. I go to the chat box and I've seen someone asking how many advantages are there of rusting. There are several of them, but I can give you a few. Advantages of rusting. Number one, rusting helps to clean the environment. How? Those metals, once they rust, they are decomposed and therefore will clean the environment. Number two, rusting helps to add nutrients to the soil, because now that iron will go to the soil. That is the second one. Number three, rusting will create income, because we will need methods to prevent rusting. So it has an economic value. It is going to create employment. You'll need someone to do painting. You need someone to do galvanization, and so on and so on. Lois, am I clear up to that point? I think that was your question. Yes, Lois Minor? Okay. I think she's okay. So that was the area number 3. We can go to area number 4 now. And area number 4 is now water and hydrogen. What do you need to understand? The first thing is an experiment on burning hydrocarbons. Number 2, reaction of metals with water. Reaction of metals with water. And the third one, it is reaction of metals with steam. So I can just share the question for 20, I can see now 2023. 2023. Ndo nilikuwa nimeifungua hapa initially. Think it was question number 18. So question number 18. This question is simply testing reactivity of metals with water. Please listen to this. Not all metals react with cold water. Like for the first 20 elements, we know that potassium and sodium react potassium reacts explosively with water. Sodium reacts vigorously. Calcium also reacts vigorously. Magnesium, or we can say calcium reacts moderately. Calcium reacts moderately. Magnesium reacts very slowly. So now the question was, state and explain the observations made. In the first one, beryllium, we know, we saw that in group 2 elements, reactivity increases as we go down the group. So the first one, there was no reaction. But now the question is observations made. What are you expecting? We are expecting bubbles. So we can say no bubbles, or we can say the phenolphthalein indicator will not change to pink. You can see they are saying reject no observable change because the question is on the observations. So the first one we say no reaction or does not react, therefore the solution remains colorless. This is because the question is tied to the observation. Roman 2, the bubbles, this is magnesium. What will happen is that bubbles will be formed slowly. So we can say the observation is that pink color forms after some time. You can see how we are using our words. Pink color forms after some time. Why? Because magnesium reacts slowly with water to form magnesium hydroxide. In the test tube 3, is that there is bubbles or there is effervescence, or we can say the solution turns to pink almost immediately. And the reason is because the reaction is vigorously. So you can see this is the topic for water and hydrogen, but you realize that I've just dealt with it on water. I've not spent much time talking of hydrogen. Unless there is anyone who needs us to have a look at Solia 2024. But before we do that, anyone who has a question, if you have a question, please feel free to ask. Okay, maybe I can just show you the question for 2024. Swali ya 2024. I think walichora ile kasampo yenye tumezoea. Good. This is how it was tested in the year 2024. Now, 2024, ukiangalia vizuri, walileta the setup. Unaambiwa the setup was used to investigate. The setup was used to investigate the properties of a burning candle. So once we are burning candle in air, we need to understand one thing. It produces water and carbon dioxide. It produces water and carbon dioxide. Okay. I've seen your question, Valentine. So I'm saying this. What will happen is that once we burn candle, it will give us water and carbon dioxide. So the water here, what is being tested here is the chemical test for water. So cobalt-2 chloride will change from blue to pink. That is the observation. Cobalt-2 chloride will change from blue to pink. Then, now the carbon dioxide itapitishwa, itawekwa hapa kwa maji, and the rest will be taken to the suction pump. So, number one, explain the observation made in the YouTube. So this is question number 9. So I can take you through question number 9. You can see the observation. Observation is that the color of anhydrous cobalt-2 chloride changes from blue to pink. Blue to pink. Explanation, this is because anhydrous cobalt-2 chloride will absorb water to form hydrated cobalt-2 chloride, which is pink. Now, the next question now on that is explain how the pH of distilled water changes. We know that the distilled water, the pH of distilled water is always 7. It is neutral. Distilled water is neutral. Therefore, it has a pH of 7. But now, in this case, the moment it absorbs water, not water, but carbon dioxide, the moment it absorbs carbon dioxide, is going to form weak carbonic acid. So the observation, they'll explain how the pH of the water changes with time. Observation is that the pH of the water will be below 7. Why? Because Carbon 4 oxide dissolves to form weak carbonic acid. It dissolves to form weak carbonic acid. Then the last part is the role of the pump. We just admit, then we continue. The role of the pump, you can see, I've said the pH decreases or it drops below 7. But once you are giving your answer, your value can only be between 4, 5, and 6 because this is a weak acid. But the moment you say the pH decreases, that is enough explanation. Why? Because it dissolves to form weak carbonic acid. Then the purpose of the suction pump. This is to suck the gases through the apparatus. It is to suck the gases through the apparatus. Unless there is any question, we can go to the next area. Anyone with a question? Okay. We can go to the next area, that is number 5. Number 5 is about salts. This is the salts that is tested in form 2. Ile salts ya kutestiwa form 2. What do you need to know once we are dealing with salts? Once we are dealing with salts, these are the key things that you must know. Number 1, what is a salt? And you name the 4 types of salts. We have the normal salts, we have the acidic salts, and we have the basic salts. Number 2, state the application of the solubility of salts. That is, all carbonates are soluble except, that is what we mean. Number 3, now I have reminded you on the solubility. For all carbonates, they are insoluble except those of group 1 and ammonium. But we need to know there are some carbonates which don't exist, like carbonate of iron. So we just proceed. Another one is about sulfates. Also, sulfates are soluble except lead, barium, calcium. Then we say calcium sulfate is slightly soluble. For chlorides, we know them. All chlorides are soluble except those of silver and lead, but we know lead chloride is soluble on warming. All nitrates are soluble. Then there is something here which is important. All sorts of sodium, potassium, lithium, and ammonium are soluble in water, and all sorts of lead are insoluble except lead nitrates. That is just a reminder of solubility rule. Another thing is description on preparation of salts. That is whether soluble or insoluble. And you need to know for soluble salts, the reaction involves use of excess metal for soluble salts. Once we are giving you explanation, ensure that you are using the term excess. Like for instance, add excess magnesium oxide to dilute hydrochloric acid. We have to use excess to ensure that all the acid has reacted. Then after that, we filter to obtain the soluble salt as a filtrate. Then we evaporate the filtrate to saturation. You allow it to cool in order to form crystals. Then you dry the crystals between filter papers. For insoluble salts, we mix the 2 reagents, that is, a soluble and a soluble salt, in such a way that we get insoluble plus soluble. And that means after that, we filter to get the insoluble salt as the filtrate. We get the insoluble salt as the filtrate. Terms and conditions apply, and there is something here you should note. For preparation of our insoluble salt, we use salts of sodium, potassium, and ammonium. They are the ones that we are going to use. Like for instance, kama tunataka zinc carbonate, we are going to use, we had sodium carbonate plus zinc sulfate. So by doing so, we are going to get zinc carbonate, which is insoluble. Then I've said salts of sodium, potassium, and ammonium are prepared using either procedure of titration or using mole ratio. Then the next thing that you need to know is the effect of heat on salts. Then the next one is effects of salts when left exposed to the atmosphere. These are hygroscopy, efflorescent, and liquescence. Then the last one is describing the procedure in preparing salts when given the reagents or not. Sometimes you are given the reagents, other times you are not given. And the last one is the uses of salts. How has this area been tested? This is a fertile ground for testing. You can see how it has been tested over the years. 2020, paper 1, it was tested 10 marks. 2021, 3 marks. 2022, I don't think whether it was tested. 2023, 6 marks. And 2024, 3 marks. Someone to tell us which year would you like us to go through? Unataka tuangalia mwaka gani? Or we can look at it at our own time.
2024.
2024, very good. Let me take you through the question for 2024. I can see Valentine was talking of okay. Valentine, you had typed, did you mean 204 or the previous chart? Were you talking of 2004 or you were talking of 2024? Valentine? Okay. Sawa. So let me take you through the question for 2024. I think here is 2024 about salts. Should be somewhere here. So let me just go to 2024. Uh, 2024. I think I'm almost there. They tested on a preparation of ammonium nitrates. I know that is the question. Good. Can we have someone read question number 19? Question number 19, someone to read? Okay. So for question number 19, you are told to describe how ammonium nitrate can be prepared, starting with ammonia as the only nitrogen containing compound. This question was very challenging for students. Why? Because it was a guided question. That meant the student must start with ammonia. So tunaanza kujiuliza maswali. Ni ammonia pekee tuko nayo. How else do we do it? So this is how the question was tested. What was required of you is that first you need to know we have to burn ammonia in air using a catalyst. That is the catalytic oxidation of ammonia. So we burn ammonia in air to get nitrogen 2 oxide. Number 2, you expose the nitrogen 2 oxide in air to get nitrogen 4 oxide. Then after that, you dissolve it in water to form nitric 5 acid. I repeat, number 1, you burn you burn ammonia in air in presence of platinum catalyst to get nitrogen 2 oxide. Next, you expose the nitrogen 2 oxide in air to get nitrogen 4 oxide. Number 3, you dissolve the nitrogen 4 oxide in water to get nitric acid. Then, after that now, what else do? We react the remaining ammonia with nitric 5 acid. This question was a high order thinking. You can see how it was tricky. So I can just take you through the marking scheme, number 19. Number 19. So you can see ammonia is oxidized to nitrogen 2 oxide in presence of platinum catalyst at high temperature. Nitrogen 2 oxide is further oxidized in air to form nitrogen 4 oxide. Dissolve the nitrogen 4 oxide in water to form nitric 5 acid. Then the remaining ammonia is reacted with nitric 5 acid to form ammonium nitrate. So that is how the question was tricky. Why was it that tricky? Because we were told to start with ammonia only and the only containing nitrogen. So you were just to use ammonia only. So it was the responsibility of the student to prepare nitric 5 acid first. Then after preparing the nitric 5 acid, you react it with ammonia. I've seen others wakisema tuangalie 2020. Think I have 2020. Is this 2020? This is 2021. So here is the question for 2020. I just need to take you through the preparation of salts. So 2020, the preparation of salts. So just go through it pole pole. 2020. There must be such a question, and there were several of them. Good. This is the first one. Huh? You can see the first one was action of heat on nitrate. So you heat lead nitrate, you get lead 2 oxide plus nitrogen 4 oxide plus oxygen. That was the first one, action of heat on salts. Then I need to go to the next. Good. Number 21. You are told salts may be classified as either soluble or insoluble. Then you are given some reagents here. You choose the ones that can be used to prepare a soluble salt. The reagents that we can use here to prepare a soluble salt is an acid plus an oxide. So we take nitric 5 acid plus barium oxide. Then for insoluble salt, nimewaambia we use a sodium salt plus a soluble salt plus another soluble salt to give us a soluble plus insoluble. So we take lead nitrate plus sodium chloride. Lead nitrate plus sodium chloride. Then the next one is describe how a soluble salt is obtained from the solution. This is now the process of crystallization. How do we do it? You evaporate the mixture to saturation, allow it to cool in order to form crystals. That is what we need. That is the next question. Let me see the other one. I think those are some of the questions that we can have. I know there is another one which was borrowing concept. And therefore, I think we can now just proceed. So that area is highly tested. Please, you don't need to ignore it. The next one is effect of electric current on substances. Number one, there is definition of terms. That is the anode, the cathode, electrolytes, a binary electrolytes, the process of electrolysis. Then you need to know how to draw and label the diagram for electrolysis. You show the direction of the flow of current and the flow of electrons. Then you need to know how to state the observations made, writing equations at the cathode and the equation at the anode, application of electrolysis. And this is very important point. For binary electrolyte, the compounds must be in molten form, or there must be presence of heat. How has it been tested? The area, I think 2023, I had seen such a question. 2023, it's like I forgot to update. Let me just see. It's like niliona swali ya 2023 hapa. Let me try to see. 2023, it's like I saw such a question. Yes, here it is. 2023. Unaambiwa a laboratory assistant wanted to investigate effect of electric current on substances. Hapa akatumia graphite, hexane. Then graphite, mercury. Graphite, aqueous sulfuric 6 acid. Then the question is this. Explain why in A it not light. This is because hexane lacks delocalized electron. It's not a conductor. That is what you need to understand. Then Roman 2. In B, the bulb lights, but no electrolysis took place. The definition of electrolysis is when electric current is passed through a compound and the compound is decomposed by the current. So the reason why no electrolysis took place in B is because mercury contains delocalized electrons. It contains delocalized electrons. So if it contains delocalized electrons, it cannot be decomposed. It will conduct electricity by use of the mobile electrons. Then if you have a look at C, it will become decomposed. Let me see whether there was such a question. C, electrolysis took place. This is because sodium sulfuric 6 acid contains mobile ions. Therefore, it is decomposed by the current. Can see some questions in the chat. Is there a difference between being molten and aqueous? This is a very good question. There is a very big difference between molten and aqueous. And I can see Gates has responded to the question. Thank you so much for responding to that. Molten is a binary electrolyte. It contains one type of cation and one type of anion only. Aqueous, it has 4 types of ions. It is the ions which are already there, plus now hydrogen ions and hydroxide ions. And this poses the question like, I don't know whether you have come across this question. Unaambiwa, explain why during electrolysis, during extraction of sodium, we don't use aqueous sodium chloride, but we use molten sodium chloride. This is the reason. If we use aqueous sodium chloride, at the cathode, we are going to discharge hydrogen gas and not sodium. So there is a big difference between molten and aqueous. Thank you so much for responding to that. So I think I can just go to the next unless there is anyone with a question. So can take you through the next area. This is elements, and I'm just talking of 2. I know you might be wondering, why am I not talking of nitrogen and its compounds, chlorine and its compounds, sulfur and I'm not talking of nitrogen and its compounds and chlorine and its compounds. This is because nitrogen itself is a gas. So hiyo tutaisoma tukisoma mambo ya gases. Chlorine itself is a gas. So hiyo tutaisoma tukisoma mambo ya gases. So elements have there is very close similarity between carbon and sulfur. What are the similarities? Carbon and sulfur, they both belong to group 4. They both belong to group 4. And therefore, there is one unique characteristics of them. That is, they have allotrophy. They have allotropes. Like sulfur, iko na aerobic monoclinic. Carbon iko na graphite na diamond. That's why nimeziweka pamoja. So, definition of terms: amorphous, allotropes, transition temperature. Then you need to know the diagrammatic representation of allotropes of carbon, that is diamond and graphite, and the diagrammatic representation of allotropes of sulfur, that is rhobic and monoclinic. You also need to master uses of diamond and graphite based on their physical properties. Then the next one, there is physical properties and chemical properties, preparation of rhobic and monoclinic sulfur, flowers of sulfur. How has it been tested? 2021, 2 marks, 2022, 4 marks, 2024, 3 marks. Which year would you like us to go through? Someone can unmute and say, or you write it in the chat. Or if you need us to move to the next, just say we move to the next.
2022.
Yes?
2022.
Okay, someone is saying 2022 and another.
2022.
Okay, 2022, 2022, then there is 2024. So I'll start with the 2022. I think this is 2022. I need to use the scheme. So 2022, we need to get the question for these. Let me just Good. Question number 15. Two allotropes of carbon are graphite and diamond. Explain why the density of diamond is higher than that of graphite. This is because diamond has tetrahedral structure with atoms forming 4 covalent bonds, while the graphite, each atom forms three covalent bonds. Then we also say the layers in graphite are held by weak van der Waals forces, so they can slide over each other. So this is a question that is testing on chemistry of elements. Part B, give one use of the following. Graphite, it is used as a lubricant, and the reason why it is used as a lubricant is because it is slippery or it is soft. Diamond, it is used to make drilling bits. It is also used to make ornaments. For drilling bits, it's because it is very hard, and the reason why it is used to make jewelry is because it is shiny. So that is the question. Someone was also suggesting 2024. Let me have a look at the question for 2024 about chemistry of elements. Okay, I will respond to Valentine's question. Let me first have a look at the question for 2024. Question for 2024. I think I need some time to get it, but I know it was there. So I think I just go ahead. I will respond to that. Then someone is asking allotrophy and okay. So thank you, Gates, for that explanation. But thank you. Allotrophy is the term that we use for chemistry. Polymorphism, you'll just be making your work difficult because you realize that it is going to complicate your story. Just know that simple term, allotrophy. So that is what you need to understand. Thank you for that response. I think I can just proceed to the next area. Now, the next area is very, very key. It doesn't mean that the other areas were not key, but this one is very key. You need to understand this. In chemistry, from Form 1 to Form 4, you have only covered 17 gases. How were they covered? In Form 1, ulisoma mbili, oxygen and hydrogen. That is the gases that we are dealt with in Form 1. In Form 2 pia ulisoma mbili, carbon 4 oxide and carbon 2 oxide. That was in Form 2. Form 3 mmesoma 13 gases. I will remind you. The first one was nitrogen, nitrogen 1 oxide, nitrogen 4 oxide, nitrogen 2 oxide, ammonia. So nitrogen and its compounds by itself, it gives us 5 gases. That is nitrogen, nitrogen 1, nitrogen 2, nitrogen 4, ammonia. Then sulfur and its compounds gives us 3 gases. That is sulfur 4 oxide, sulfur 6 oxide, hydrogen sulfide. Then chlorine and its compounds gives us 2. That is chlorine itself and hydrogen chloride. Then the remaining 3 gases now, it was because the organic chem 1. Alkanes form homologous series. So we just took methane as a representation, ethene as a representation, ethine as a representation for alkynes. What do you need to understand? Wherever you are dealing with a question for gases, this is very, very important. Number 1, what do you need to understand? You have to identify the correct reagents. Identifying the reagents correctly. Number 2, you draw or you complete a setup to prepare a gas. Then I have a good news for you. Wherever you are told to complete a setup to prepare a gas, just pass it through concentrated sulfuric 6 acid and you collect it using a syringe, except when the gas is hydrogen sulfide. I think I can highlight that. These are the gases which cannot be dried using hydrochloric acid. The first one, not hydrochloric, but Kong sulfuric 6 acid. The first one is hydrogen sulfide. The other one is ammonia. And the third one is alkenes. The rest, if it is through Kong sulfuric 6 acid, then you collect it using a syringe. You'll thank me later. That is we call them survival tactics in chemistry. Now, we just proceed. I've said you need to know how to complete the setup. Another thing that you need to understand is the correct methods of gas collection. Ukipatana na swali yenye inahitaji collect gas na wewe umesahau, huwezi jua kama tunatumia around the downward delivery ama ni upward delivery. Just use a syringe. You will score all the marks. Use a syringe. A syringe can collect all the 17 gases that we have. Another thing is to identify the mistakes in the setup. These are the possible mistakes. Wrong reagents, that includes wrong drying agent. Use this funnel, which is left hanging. Then there is wrong, I've talked of wrong drying agent, and there was wrong method of gas collection. These are key things that you need to know once you're identifying a mistake. The mistakes are as follows. Nimesema the first one is wrong reagents. If the reagents are okay, check whether if it's a diesel funnel, is it long enough? If the diesel funnel is long enough, check whether the drying agent is correct. If the drying agent is correct, check the method of gas collection. That is how we identify the mistakes. Next one, you need to give the correction for the method of gas collection. The correct method of gas collection. Hii ndo nimesema, all the 17 gases I've listed above can be collected using a syringe. Then the next one, you need to see the uses. After that, the confirmatory test of the gases. I can give you the confirmatory test of all the 17 gases. They are there. So you need to know the confirmatory test of any of the 17 gases that I've listed. I can give you the confirmatory test of any of them. Then next one, you need to know how to write a balanced equation, then identifying the gases with similar properties. Like for instance, hydrogen, carbon 2 oxide and ammonia, they are and hydrogen sulfide, they are used as drying, not drying, but as reducing agents. Because kuna hii swali inakujanga, unaambiwa state another gas that can be used. You need to group them in terms of the elements which have, not elements, but the gases which have similar properties. Another thing is that sulfur 4 oxide and chlorine, they are both bleaching agents. But how do they differ? Sulfur 4 oxide bleaches through reduction, while chlorine bleaches through oxidation. So we need to master these, some of these properties. We continue. And these are very important points. This one, you just need to master them. Sorry. These very important points. Number one, I think I've said them, but I will just repeat. All gases can be collected using a syringe. Number two, all gases can be dried using concentrated sulfuric acid, except ammonia, which is dried using calcium oxide, hydrogen sulfide, which is dried using anhydrous calcium chloride, and I think I can add another one. I think I can add another one. I've also said alkenes cannot be dried using sulfuric acid, but we use, so I can add alkenes. So I can talk of alkenes. And once I talk of alkenes, I mean into brackets, I can use example, ethene. Ethene can be dried using any of the other two drying agents, but not sulfuric acid. Then the other thing is that only ammonia is the alkaline gas. This is the only gas that is alkaline, ammonia. Hizo zingine, they are either neutral or acidic. Another thing is that the gases which are collected over water, they are all neutral because it means they don't dissolve in water. Now, let me go to the questions. How can you use potassium permanganate? Where is that question? How can you use potassium permanganate? We call it potassium manganate 7 to distinguish between hydrogen sulfide and sulfur 4 oxide. Good, I can see potassium manganate 7 So one thing you need to know is that potassium manganate 7 will change from purple to colorless if you add it to sulfur 4 oxide gas, but it will have no, it will not have any effect once we use hydrogen sulfide. It will not change from purple to colorless. This is because potassium manganate 7, it is an oxidizing agent. So it will oxidize sulfur 4 to sulfur 6 oxide. Potassium manganate. So potassium manganate 7, remember acidified, never forget. Yeah, thank you so much. So it decolorizes. But now I've said this. I don't think whether manganate 7 will change to colorless once we had potassium manganate 7. Valentine, can you hear me?
Yes.
Okay, I think let me just confirm, but I think manganate 7 and dichromate 6, they are used to confirm they are used for sulfur 4 oxide. Let me just confirm. And as we have been told that it must be acidified, so just a minute, I confirm. Uh-huh. Okay. They are saying it will fade, but I think the rate of decomposition, the rate of changing from purple to colorless is more in sulfur 4 oxide than once we use hydrogen sulfide, because sulfur 4 oxide is both a reducing agent and an oxidizing agent. So in this case, if it is reacted with acidified potassium manganate 7, I think in both cases it will change from purple to colorless. But now the difference is that the other one is going to oxidize the sulfur into sulfide ions. So if we had acidified potassium manganate 7 to sulfur, I think it's going to oxidize the sulfide ions into sulfur. So we are going to have some yellow specks of sulfur. I don't know whether I've answered your question, Valentine.
Yes.
Okay. So which year would you like us to go through? There is 2024, 2023, 2022, 2021, 2020. Can see in the chat 2021. So I can see someone is saying 2021, and I will just take you to 2021. 2021. The question is testing on gases. I can share the scheme. Okay, 2021. It was tested 14 marks, mambo ya gases. So I can take you through them. This was the first one. No. This one is more of electrochem. So it is still talking of the gas. Good. Question number 9. The property tested here is a carbon 2 oxide and a gauze compression. So you can see dry carbon 2 oxide. Then the dry carbon 2 oxide ikichomwa, it will form carbon 4 oxide. Then the carbon 4 oxide ikiwekwa hapa, it will form a white precipitate. It will form a white precipitate. So the first question is this. State the precaution once we are carrying out this experiment. This experiment must be carried out in a fume chamber. Why must it be carried out in a fume chamber? Because carbon dioxide is poisonous. Another one, say the observation made in the boiling tube, a white precipitate will be formed. Those are already 3 marks. I continue. I need to show you another question for gases. You can see this question is for the chemistry of elements, the one I was talking about. There is another one here. You are told, okay, this one is for reaction rates. Another question is here. Describe how dilute HCl and blue litmus paper can be used to distinguish between solid samples of sodium carbonate and sodium sulfite. How is this question testing on gases? Preparation of carbon dioxide. You react an acid with a carbonate. Preparation of sulfur oxide. We react a sulfite with an acid. So how do we do this? You can see to different test tubes or separate test tube, you add dilute nitric 5 acid. You place a wet blue litmus paper at the mouth of the gas jar. What is going to happen is that the two gases produce acidic. But one unique thing about sulfur oxide produced with be a breaching agent. So you can see, plate wet blue litmus paper at the mouth of the gas jar. Then both turns to red. Thereafter, one of them changes to white. The sample that produces changes to white is the sulfite. So they are testing. How do we prepare sulfur oxide? How do we prepare carbon dioxide? And now, after preparing them, the litmus paper is not enough. You need to know that litmus paper, it changes to red, then to white, because sulfur oxide is sulfur oxide is a bleaching agent. So you can see, I was saying you need to understand the unique nature of some gases. The gases which do bleaching, there are only two, sulfur oxide gas and chlorine. What is the difference between the two? Chlorine bleaches through oxidation, sulfur oxide bleaches through reduction. So those are, I think those are around 9 marks so far. Let's see whether we have another one for the gases. Another one for the gases. Good. This is another one for the gases. Articles made of copper turn to green when left exposed for some time. Why? This is because of formation of copper 2 carbonate. How do we form the copper 2 carbonate? This is because copper reacts with carbon dioxide to form copper 2 carbonate. And remember, copper 2 carbonate is green. Copper 2 carbonate is green. So those are 10 marks. Let me see. Yeah, there is another one here. And if you can, nataka muangalie the two questions that I'm going to show you. This is the question for 2020. Because you might be asking yourself, why am I wasting a lot of time taking you through the years, how the questions have been tested? Look at this question. Complete the following reaction. And then oxalic acid or ethanoic acid, it will be decomposed to carbon 2, carbon 4, and water for 1 mark. So the question's marks becomes 12. Name another reagent that can be used to prepare carbon dioxide by dehydration. That is methanoic acid. That is methanoic acid. Then, before I go to the next question, hizi maswali ni mingi sana. Those are already 14 marks. I can show you how it came in the year 2024. I think I have 2024. Sorry. Just have a look at this question for 2024. 4 years down the line, how the question was tested. I'm just trying to show you why it is important to be guided by the past papers. You can see how they use the question. 2020, look at this. This is 2024 and this is 2021. So 2024 walileta equation ikiwa imejaa. 2021 the way sorry, not 2021. 2021 walileta equation mwanafunzi akamilishe. 2024 they started with the equation ikiwa complete. So you can see the difference. Then wanapea mwanafunzi amalizie. So that is how they keep on repeating the same thing, and it's good that we be on in touch. So those are 14 marks. We go to the next one. This is laboratory preparation of nitrogen gas. So hata hizo marks ziko 17 because these are another 3. Preparation of nitrogen gas. We react sodium nitrate plus ammonium chloride. Complete the setup. Nimewaambia ukipatana na swali ya complete the setup na ujui whether we collect it over water or what, my friend, this is what you just do. We attach syringe hapa. Attach the syringe like that. We call them survival tactics. Why are we using a syringe? All the gases, they will exert some pressure. Therefore, all the gases that we have, they can be collected using a syringe. So this is how we survive. Those are 17 marks now. 1 year, 17 marks in paper 1. So that is it. Maybe because nimewaonyesha ya 2024, I can just go through the question for 2024. Can just take you through the question for 2024. The question for 2024, you have to identify the reagents. So this X should be conch sulfuric 6 acid. Y should be calcium hydroxide, not calcium hydroxide, but sodium hydroxide to remove the carbon dioxide. And this one now will be carbon 2 oxide. Let's see. Identify X and Y. Nimesema X ni conch sulfuric 6 acid. The role is a drying agent. Y is sodium hydroxide. The role is to absorb carbon dioxide. Then the last one is state the property that allows the gas to be collected. Wherever you find that a gas is being collected over water, this is because it is slightly soluble in water. So we are going to say it is slightly soluble in hot water. So this is the answer for question number 20. You can see conch sulfuric 6 acid to dehydrate. Calcium hydroxide or sodium hydroxide or potassium hydroxide to remove carbon dioxide. Then the reason is carbon 2 oxide is slightly soluble in water. So please, these 17 gases that I've given you, ensure that you have mastered them. Method of preparation, the reagents used, and so on and so on. That is it. I can take you to the next area unless there is anyone with a question. So, part number 9, which is now, we are still remaining with around 2 more areas. Can see there is a question in the chat. Okay, thank you. I think the drawing is now not visible. Okay. When using a syringe, does it have to be calibrated? It is not a must, but it's good to calibrate it because sometimes you might need to measure the volume. So it's good we show the calibration. Thank you for that. So Just another, we see. Ryan, has the drawing disappeared? Ryan, just confirm.
Yes.
Okay, okay. So there is another one that we call the laws and principles. Na kuna kitu moja nataka tujue, which is very important. In chemistry, there are 9 laws. Yani, we have 10 commandments, but we have 9 laws in chemistry. 9 laws and principles. Number 1, the Boy's law. Number 2, Charles' law. Number 3, combined gas law. Number 4, Graham's law. Number 5, Gay-Lussac's law. Number 6, the Avogadro's constant, which says that 1 mole of a compound contains 6.023 times 10 power 23. Then we have the Le Chatelier's principle. This is in form 4. We have the A's law and we have the Faraday's law. These are only 9 laws. You need to master them. Now, how do we test the concepts in these laws? The concepts in these laws are tested as follows. Number 1, you need to state the law correctly. And after stating the law correctly, you need to know how to apply the law. How has it been tested? 2021, 5 marks. 2022, 2 marks. 2023, 4 marks. 2024, 4 marks. Which one would you like us to go through? If you keep quiet, I'll just take you to 2024. Or maybe if it's okay, I can just go to the next. Is there any of the years you would like us to go through? You can unmute and say it, or you write it in the chat. Yes? Ryan?
2021.
2021. Yes, Ryan, you have said 2021.
Yes.
Okay, okay. So, I take you through 2021. 2021 about the gas laws. Okay, juu hapa naelekea kumaliza, wacha nimalize kwanza. I just need to be sure haiko hapa mwisho. So, I know there was a question for Graham's law. Let me just confirm. 2021. Uh, 2021. That's a question I had seen for gas laws. Okay. 2021. Good. Question number 15. State the Gay-Lussac's law. This stating of the Gay-Lussac's law is not very common, but you can see it was tested. So how does it state? It says when gases react, they do so in volumes that bear simple ratio to one another and to the products. If gaseous, volume, pressure and temperature kept constant. So you need to understand how to state the Gay-Lussac's law in this question. Then next one, wakaleta swali. 180 of nitrogen 4 was reacted with 400 of oxygen. Hii swali tunafanyanga na something we call trial and error. How? We don't know which one was accurate. Kwa hivyo, after writing the equation, kama hii ni 180, hii ni 180, alafu hii ni 400. We don't know which is which. So we try to apply the concept that we know and see whether the one that is working. So if 2 is representing 180, so it means if 2 is 180, then the volume for oxygen will be 90 because the ratio is 2:1 and we are going to form 180. That is if we assume the nitrogen 2 oxide was accurate. But if we take oxygen to be the one that is accurate, this one is going to be 400. And 400 will require 800 of nitrogen 4. 800 of nitrogen 4. Then now we analyze it critically. This is option A yenye iko na 180 na 90. Hii ni option B yenye iko na 800 na 140. Sorry, 800 and 400. So we ask ourselves, which one is meeting our budget? The rules of life is that don't spend more than you have. So which one do you think is applicable in this case? Someone to attempt? Which one do you think is meeting our budget? Or which one is meeting the conditions? Someone to unmute and say. Gates, can you attempt? Or someone and unmuted? Who will give us the one that is fitting our situation here? Yes, Leah? Leah, which is?
The first one.
Very good, the first one. So, wakati tumeulizwa, calculate the total volume. You underline the term total volume. The total volume will be first, out of the 400 of oxygen provided, we are only using 90. We are only using 90. So out of the 400, 310 will be unreacted. So the total volume will be 310 plus the 310 plus 180 because we have 180 of nitrogen 4 which is being formed. So the total volume will be 310 plus 180. It will give us 490. It will give us 490. So those are 2 marks. Not 2 marks, but 3 marks. Let me see whether there is another question for gas loss. Because I had said it should be. Let me clean what is on my screen to avoid confusion. So, I don't know whether I've skipped it, but I think there was another question. So there's no problem. There's no problem. So that is how we respond to the question on gas laws and principles. So you can go now to the next one. This is another area where I know some of us don't like, but it's an area that is a must to be tested. Ukiangalia hiyo analysis yangu, 2020 6 marks, 2021 6 marks, 2022 8 marks, 2023 6 marks, 2024 9 marks. What are the concepts tested? Number 1, calculation of moles, defining empirical and molecular formula, determining the empirical and molecular formula, relationship between moles, mass, and RAM, preparation of standard solution, dilution, and titration. Is there any of the years that you would like us to go through? Someone to share, if there is any. If we don't have, we can just go to the last part.
2020.
2020? What have you said? 20?
24.
Okay, 2024. Let's have a look at how the question was tested in the year 2024 about moles. 2024 about moles. So we just go straight. The first one, was question number 7. This was about the calculation of the empirical formula, finding the value of x. And you can see the working for number 7. You can see the working for number 7. This is an area that I know you are conversant with. You find the value of x. So the formula was Na2 carbonates, 7 molecules of water. Those are 3 marks. I still continue. So hiyo ni empirical formula. Those are 3 marks. I go to the next concerning moles. Go to the next, that is concerning moles. And just a minute, I reach there. Yeah, here is another question number 18, whereby you are supposed to apply the mole ratio. Question number 18. So this is 1 mark, and I think there is another 1 mark. So I can show you the working for question number 18. Question number 18. So you can see the working for question number 18 on your screen. So you can see, after identifying the catalyst, you find the moles. It was testing on finding the moles. The other one was to apply the molar gas volume. Those are 3 plus 3. We have 6 marks. Let's get the remaining 3 marks. I'm just hoping I've not skipped it. Yes, this was the remaining 3 marks. This is question number, if this is 20, so the last one was question number 21. Question number 21, you can see the working. So in that year, moles last year in paper 1, it was tested 9 marks. It was tested 9 marks. But in paper 2, the same year was tested 3 marks. So you can see 9 plus 3, those were already 12 marks. And therefore, I can take you through the last point, and that is radioactivity. What do you need to understand about radioactivity? Number 1, definition of terms. Number 2, identifying the type of radiations. Then we need to know the characteristics of radiation. We need to understand the radioactivity decay, differences between nuclear and nuclear reaction and a chemical reaction. We also need to know half-life, that is the calculation from the graph, and also once we are given the numerical. We also need to know effects of radiation. 2020, 3 marks, 2021, 3 marks, 2022, 3 marks, 2023, 3 marks, 2024, 2 marks. Which year can we have a look at?
(2020).
2020. Okay, let's have a look at 2020 as our last part. 2020. So here is, I think this is 2020. So tutafute swali ya radioactivity hapa kwa 2020 radioactivity. So for radioactivity at 2020, let me have a look at the equation. Just need to have a look at the equation so that I can we can elaborate on it. Mhm. Okay, here is the question for 2020. So you were given the radioactive na wakauliza value ya x. The first part was cancelled because it was not making sense. So all the marks were transferred to the next one, whereby you were to calculate the half-life. So umeambiwa the half-life of thorium-228 is 1.9. If after 5.7 years, the mass was found to be 1.25. So we divide 5.7 by 1.9. We realize those are 3 half-lives. So we take 1.25, previous one was 2.5, previous one was 5, previous one was 10. So the answer was 10 grams. And you must give the SI units. You must give the SI units. Someone is asking, can I show you how to calculate the half-life from the graph? Okay, let me see whether I have a question for the half-life from the graph. But this is basically what we do. If we had been given the graph, like for instance, let me just try to sketch the graph like this. And it looks like this. So the half-life tunaweza angalia hapa. Let's say hapa it is after 5 days. Not 5 days, but 5 grams. And here it is 10 grams. I don't know which one. So what we are going to consider is the time it takes to decay to half of its mass. So these are days. Let's say these are days. And we realize that here it is 40 grams. And here it is 20 grams. So unaweza ukapata hapa ni 5, hapa ni something like 15. So ukiulizwa the half-life, you realize that it was 40 grams after 5 days. Then by 15 days, equal 20 grams. So you check from the graph, how long does it take to decay to half of its original mass? So we are going to say it is 40 to 20. So the half-life will be 15 minus 5. I don't know who had asked that question. Lisandra, have I explained? Is it okay now? Lisandra.
Yes, thank you.
Okay. So those are the main areas that we are remaining that we are to deal with. I've just dealt with 11 areas, which are very, very important. Unless there is any question at this point, anyone with a question before I welcome Mr. Paul to say something and we have someone to pray. Mr. Paul, can you hear me?
You, Mr. Mutiso, I can still hear you.
Okay, you can say something.
I have been following the lesson. Oh, all right. So the lesson has been good. Maybe I would ask, I can see Yusa. I can see the person named Yusa has, he has muted. So thank you, Mr. Mutiso. At least the network has been good on our side.
Yes.
And then I can see some questions. This is Mina Lois saying, thank you so much, sir. It was such a productive session. That is interesting. Lysandra had asked, can you show how to calculate half-life from the graph. I believe you have already done that.
Yes, I've done that.
So thank you so much. At least the lesson has been productive, and thank you, students, for staying put. Asante.
Thank you so much. Can we have someone to close the lesson with a word of prayer?
I think I should get the privilege to do that, sir. Kindly, if you allow me. So let us pray. Mighty God and everlasting Father, thank you for the lesson that we have already had. May you bless the students with good grade, and may you expand the territories of the teacher for offering his best to the student. Bless him and lead him through as you lead the students through. Because I pray this in the name of Jesus Christ. And now, all students, let us say, may the grace, if you can unmute, please. If you can
For
unmute,
Lord
please.
Jesus
May the
Christ,
grace
Well,
and the love
Jesus
of
Christ,
God
and the love of God
And the love of God and the fellowship of the Holy Spirit
be
rest
with us
now
now
are forevermore.
and
Amen.
forevermore. And
Amen.
everybody say amen.
Good.
Bye bye. Good night, everyone. Let us meet tomorrow.